Okay, so here we are. In relationship to our coolant system, we talked about last week, Thursday, about leaks, right? How certain seals and gaskets can fail. Typically speaking, we put the system under pressure because it's normally operating under pressure. And again, in order to find out what kind of pressure we're looking at in our coolant system, we would look at the radiator cap. And that's going to tell us how much that radiator cap is rated for, okay? More often than not, it's in PSI. So 15 PSI is pretty standard. But you'd always want to verify because some systems might be slightly less. Some vehicles that are not made in the United States might actually measure it in kilopascals, which is the metric version of PSI, okay? So if you see a KPA listed on the radiator cap, you have to make sure that you either convert it to PSI or you are setting your pressure system to read in kilopascals. Again, that's just information that'll help you when you go out in the shop, because I know for a fact we have one vehicle out there. You look at the number and it's not PSI, and I don't think it clearly states that it's even in kilopascals. But you know it's not, it's a foreign vehicle. Anyways, we pressurize the system, we check the needle, we make sure or verify that it can hold the pressure, okay? If it's not holding the pressure, as it's pressurized, we're going to be looking on the ground, looking over the engine block. Where in the world is this leaking from? If there's no visible signs that you have a leak or coolant's coming out somewhere, right? And it's not going to be like, oh, that's coolant. It's just going to be like a wet spot. Chase. If you can't see it from the outside, it's on the inside, which you can't see unless you tear the motor apart. Unfortunately, that's very expensive. So before you spend a lot of time going in elbows deep trying to figure out where this thing is at and taking everything apart to do an investigation, we have to apply some brain power, right? Hey, I know how this system works. I know where the water jackets are at. I know where the coolant is circulating. Where can I be looking for this before taking stuff apart, okay? Typically speaking, an internal leak is a very high likelihood that it's happening at your head gasket, as noted here. Whoops. On the notes, okay? Other places that you could potentially have an internal leak, you could actually have an engine block or a cylinder head that's cracked, okay? For whatever reason, excess pressure, fatigue, you could have a crack in the system that goes between your cylinder or combustion chamber and into where the water jacket is at, and it's leaking into that, okay? Obviously, any three of those situations are very, very detrimental. If it's a cracked engine block, time for a new engine. Cracked cylinder head, you probably need a new cylinder head, right? Not cheap. Blown head gasket. Head gaskets for the most part are not super expensive, but it's the time to go in, take everything apart to replace that. That's what's going to make it expensive.
How often is a cracked block or a cracked cylinder?
Not as often as a blown head gasket. We would want our head gasket to fail before our engine block or cylinder head. But even then, blown head gasket's not super common even, mostly because of what it's made out of. But it does happen, and we have to be prepared for that diagnosis. Again, before I actually go in and say, hey, you have a blown head gasket, I'd want to verify that with some testing. So that way, if it's somebody else's vehicle, I can 100% guarantee you it's a blown head gasket or something along those lines before starting to say, yeah, it's going to be $3,000 to fix this, right? And the customer says, okay, fix it. You go in and realize you made a mistake, right? We don't want to be guessing. We want to know. One of the ways you can know is by checking out if there's any exhaust gas in the coolant. All right, if there's exhaust gas in the coolant, that exhaust gas is also leaking into the water jackets, into the coolant, and then at the radiator cap we can test that. Okay? Simple, cheap test, and then we can go to the customer and say, I can verify that you have an issue with your head gasket because I did this test. And it came back as positive. right? You're not saying, well, I think maybe it could be it, because that doesn't give any confidence to the person that you're working on their vehicle, right? And again, there's other tests that you can go in and double check that. Another thing that you can actually end up checking is an exhaust gas analyzer. It's an older piece of equipment. It's used for emission testing more often than not. But if you get good at using this tool will actually indicate whether there's excess water vapor inside the gas fumes that are coming out the back end of the vehicle. Okay, so this is more used in our emission system. So when we get into that, we'll talk more about what exactly this is testing for. But you could hook this up to your exhaust. Okay, right? Plug it into the tailpipe, and it's going to analyze carbon monoxide, carbon dioxide, nitrous oxides, oxygen levels, and what else does it do? I can't think off the top of my head. Hydrocarbons. There you go. Okay. So the exhaust gas above the coolant level in the radiator can indicate a blown head gasket, a cracked block, or a cracked cylinder head. So again, if it's noting that we have higher amounts of water vapor coming out our tailpipe, it's again another indication, where's that water coming from? Well, the most likely source is going to be your coolant leaking into the combustion chamber. As there's an explosion from the gas, right, it heats everything up, which vaporizes the water, turns into water vapor, and it goes out your exhaust, same way as before. Okay. If you get good at this, you can actually tell which cylinder is receiving that water, and you can know specifically where that head gasket is failing before even looking at it or tearing into the system. But that takes a very, very high level technician to know how to do that. Another indication you probably have an internal leak is some of the coolant actually getting into your oil pan. Okay, remember oil is going to be flowing throughout the system. Gravity feeds it back down into the oil pan. If there's a coolant leak somewhere, that coolant is also going to end up in the oil pan. Anytime that you have oil mixed with water or antifreeze, it's going to turn a milky white color. It's going to look like milk chocolate. Okay, kind of what you see here in this bottom right-hand picture. Okay, so again, another thing that we can be looking out for is when we are changing our oil, right? As it's draining, I'm just not kind of mindlessly just letting it drain and not thinking. This is the opportunity to look at the internals of my engine, right? So I can kind of double check to say, hey, how is this thing functioning? Right? Are there any metal shavings in my oil as it's draining? Okay. What's the color of the oil that's coming out? Okay. Does it look like milk chocolate? If it does, oh crap, how is water getting into my system? The most likely cause? Coolant. Okay, which means you have a leak. Obviously, again, another outside indication your engine is burning or receiving water vapor is white smoke coming out the back tailpipe, which is not good. Okay, white smoke equals water vapor. A bluish grayish smoke, that means you're burning oil. So just by indicating the color, you can kind of start deconstructing what you need to start investigating, which can save you some time long term. Okay. All right, this is going to be important that you get all of this here. Stuck closed thermostat. Right, again, my thermostat is inside the engine block. It's in a housing. Coolant is surrounding it. I can't see it. The only way to see it is to drain out my coolant and then take some stuff apart and get at it. How do I know I have a stuck closed thermostat? Well, okay, we're going to have overheating. That's probably going to be the biggest indication that I've got a stuck closed thermostat. The thermostat's not opening, the coolant is not cycling out to the radiator to regulate its temperature. It's going to overheat. However, there are other items that could also potentially lead to overheating beyond just a stuck closed thermostat. Okay, we could have a slipping serpentine belt. How can a slipping serpentine belt cause my engine to overheat? Most people overlook this when they're trying to diagnose overheating engine. They just immediately jump to the thermostat and say, yep, it's bad, let's replace it, without actually going in and verifying that it's bad. So now all of a sudden you're taking everything apart, you spend all that time putting a brand new thermostat in, you put everything back together, you turn the engine on, and crap, it's still overheating. You just replaced a fine part. Nothing wrong with the part that you replaced. You just wasted your time and you wasted the customer's money. How can a slipping belt cause an engine to overheat? Let me ask you this. How does the water pump receive its power to pump the coolant throughout the water jacket and the engine blocks?
A belt.
A belt. Okay? Literally, the serpentine belt that's on the vibration dampener, on the crankshaft, as it's moving that belt around and powering other various accessories, it is also powering your water pump as it circulates the coolant. How can a slipping belt cause an engine to overheat?
Because it's not getting the right water amount.
Well, it's still getting the right water amount. The problem is my water pump is not turning at the rate that I need it to turn. Okay? So as it's cycling, okay, again, that's being powered by a belt. If that belt is slipping, it's not turning as fast, which means it's not cycling the coolant as quickly. Hi, am I missing a conversation here?
No, never.
Okay. So it's kind of like having your heart, right? Your water pump is your heart in the coolant system.
Yeah.
If I'm sprinting on the football field and my heart's just staying at the same beats, right? I'm not circulating the oxygen in my body. I'm going to fatigue very quickly, and my own body is going to overheat. I'm going to collapse down on the ground, okay? Because my body's saying I can't do this anymore. Same concept here, okay? So, how do I fix this particular problem? Probably need to replace my serpentine belt, which, by the way, is pretty easy to do in comparison to replacing a stuck closed thermostat, and it's much less expensive. So it's kind of weird how a simple thing like that can lead to a much more, I wouldn't say crazy diagnosis, but a crazy problem. Okay. Also, if I have a clogged radiator, that can cause overheating as well. Okay, my water pump's pumping the coolant around, awesome. My thermostat's opening up. The problem is I got a bunch of bugs in my radiator because it's right in the front of the vehicle, right? It's receiving a bunch of wind. It's also receiving a bunch of bugs. Okay, it might get clogged up. Sometimes those little fins on the radiator actually get bent quite a bit. Now as that coolant is cycling through that, the air can't go through as easily. Can't cool as well, it's going to lead to overheating. So, some interesting things there that we can actually get into goes beyond just specific components just in the coolant system. Okay? Now, we also could have a stuck open thermostat. It never closes, right? Again, what would that lead to? Overcooling the engine. Okay? Now my engine has a much more challenging time getting up to the 180 to 210 degree Fahrenheit operating temperature, which then could potentially lead to carbon deposits inside my combustion chamber, okay, which could lead to sludge because the oil is going to be trying to clean that up, which means my engine is going to be very inefficient at burning the gasoline. But just like a stuck closed thermostat leads to overheating, and there's other potential issues with that. Same thing here. We can't just simply throw the thermostat as the fault for this. Okay? We could have a locked on fan clutch. Remember that fan in front of my engine there that's hooked up with a shroud on the radiator could be stuck on constantly, which means it's pulling in air all the time, even in a cooling situation where I don't need it on. Okay? Or it could even be a shorted fan switch. Hey, I got an electric fan. Well, guess what? The computer's controlling that. The problem is I got a short, which means that the electricity is bypassing that switch, causing the electrical fan to always be on. That could also cause overcooling situation. So again, it's not just black and white in terms of our diagnosis. Oh, it's this, so therefore it has to be that. Not necessarily. Okay? This is what separates the DIY mechanic that does stuff in the garage to a technician that gets paid to do this as part of their job. Okay? You have to understand and realize that this system is built together amongst many other systems, and they all interact with one another. So that way, if you got a problem, you can't just simply say, well, 90% of the time it's this, because 10% of the time it could be something completely else. Okay, so we're just kind of introducing that idea. All right, some cooling systems do have a bleeder screw that's attached to the system. Okay, again, the radiator cap in my coolant system is designed to be the highest spot in the coolant system. So that way, if there's any opportunity for air or bubbles to be in the system, those bubbles are going to naturally rise up to the highest spot. And again, ideally, that's your radiator cap. But in some situations, it's not. There might be places where those air bubbles may be trapped inside the system. In that case, we have to be able to relieve that air inside. So the engineers might add a bleeder screw like this. Okay, so we got our bleeder screw here. I'll get to you here in a second, Emerson. This bleeder screw is literally put into a housing for the thermostat. As I'm starting the vehicle and it's turning around, I can open the radiator cap, allow some of those bubbles out, but if there are any trapped, all I got to do is kind of crack this open by a quarter of a turn. Okay, the air that's trapped inside the coolant system can go in this, and then it comes out the top. Okay, as soon as coolant starts to bubble out of this, right, then I can turn it back off and shut it down so that way I got all the air out. Yeah.
I have a question. So, yesterday I was watching YouTube,
Okay.
and then this guy put Galaxy gas into his car.
You got what gas?
Galaxy gas.
Galaxy gas?
Yeah.
I don't
And
know
it
what
is
Galaxy
going
gas
faster.
is.
I don't know.
It's for whipped
It's
cream.
nitrous. It's nitrous
Oh.
gas. It's like nitrous gas.
That's good.
It's like, and then he turned it off for like a long time, and it like got super duper cold.
Yeah.
Super cool. It was
Way
like-
cool.
Nitro.
Well, it's not nitro.
Is that
But yeah, I'm not going to get into the science behind why that worked, and we're not going to get into nitrous oxide either, unfortunately. That's just beyond what we need to have you guys learn in Auto 1. But yes, there are things out there that you can do to add, and if you understand how the engine operates and how the chemicals work, right, you can go in and manipulate things to get more power in a particular situation. Thank you for bringing that up. That's kind of a fun thing to talk about. All right, coolant systems need to be flushed at regular intervals. One thing to keep in mind, coolant does go bad.
It was on.
Coolant does go bad.
how often?
That's a great question. It depends on the coolant. Typically speaking, with IAT, right, the old school stuff, you'd probably be changing or flushing out your coolant maybe every 50,000 miles. Nowadays, with the OAT or HOAT type antifreeze, you could probably go 100,000 to 150,000 miles without necessarily needing a flush. The interesting part is this is not a very common process or procedure that people maintain themselves anymore. They just forget about it and go, hey, my car's running just fine. I don't need to worry about that. One thing that we also need to understand is beyond just coolant going bad, our coolant hoses, radiator hoses, the upper and lower radiator hose, does go bad. Okay? They become too stiff. They become dry rotted. So typically speaking, we also have to make sure that we are maintaining our coolant system by replacing our hoses regularly. But again, no one does that anymore. Okay? They don't add this as part of their service. And when they take their vehicle in and say, oh, hey, you got 150,000 miles on your vehicle, you may want to consider doing a coolant flush. People are going to be like, well, you're just trying to charge me extra when I don't need to purchase it, right? The thing is, your technician understands how your vehicle works, right? And they're trying to help you save money by preventing a major issue down the road for you. So they may say, hey, $80 to $100 for a coolant flush with new fresh coolant. That might save you $2,000 to $3,000 because whatever, right? Old antifreeze does become acidic. It becomes an acid, which means it's going to corrode things from the inside out. You won't be able to see this, okay? You won't be able to feel it until something breaks down and you can't drive your car anymore. By the way, no masks in school.
Come on, Chase, you know better than this.
Now, the fun part about this is, again, if we understand that coolant can become acidic, when the coolant becomes acidic, it actually can generate a chemical source of voltage. So I can actually take a digital multimeter, which is what DMM stands for here, and I can actually test the voltage that's coming out of my coolant. If it is over a half a volt, it indicates that my coolant is too acidic and it should be replaced. It's a very crazy concept to think about. And again, most people probably don't even know that they have a digital multimeter to begin with, or that they can perform this test. And by the way, there are kits that you can purchase that will allow you to very easily add or drain your coolant. All that we need to understand is that obviously when you are dealing with coolant, it's not like oil. You have to be able to dispose of it properly. Which usually you can bottle it up and probably take it to your local landfill. And probably they have an opportunity to dispose of that. Oh, don't do that, that hurt. Okay, anyways. By the way, here's a digital multimeter. Okay, if you've never seen one of these before, during the lab, we're starting tomorrow, you will be able to use one of these. We'll go through the process of that tomorrow. Okay. Another tool that you're going to be ending up using, a coolant hydrometer. Yeah, that's a hydrometer. It's a special coolant test used to measure coolant freeze points. Actually, hold on a second. The thing on the left is a refractometer. The hydrometer is over here on the right. Okay, there we go. So hydrometer, let me go and get you a hydrometer. What does that look like?
No.
Hydrometer. Okay, this is a hydrometer. Literally what you're going to do is you're going to take this hydrometer, you're going to stick it in the coolant, you're going to squeeze the bulb here. Okay, when you let go, it's going to literally suck up some of the coolant. There's a level right up here at the top that you want to fill up with the coolant that's in the vehicle. And then you can kind of see this like orange arrow thing that I'm kind of moving back and forth, right? That is going to float in the coolant based off of the specific gravity. Write that down.
What is that?
Okay, it's a hydrometer. It uses the coolant's specific gravity. Okay, hydrometer utilizes the specific gravity of the coolant. It's a scientific term. You can talk to your science teacher today. Hey, we were learning about specific gravity of coolant in automotive. Watch their eyes light up. What? You're actually taking scientific principles and utilizing it for a chemical process to learn how much coolant you have? Yes. What's crazy is then we can convert the specific gravity of the coolant into a ratio of antifreeze to water. And once I know the ratio of antifreeze to water, I can indicate on here the freezing point of that coolant, which is what this little arrow is going to end up pointing at. So I can indicate, oh, hey, this is good to negative 30 degrees Fahrenheit. okay, or wherever that's pointing at. So one side is the freeze point, the other side is its boiling point, because they're related. So I can know the freezing and boiling point just by the specific gravity through this instrument right here.
Me too.
Okay, these things, by the way, are super cheap. You can get these at like Fleet Farm for like less than $10, I'm pretty sure.
Is there anything at Fleet Farm that's less than $10?
I don't know. I haven't been to Fleet Farm in a while.
I was in there yesterday, there was birds in there.
Yeah, they like to hang out. It's probably warm in there, right?
When they get into like the back warehouse,
Right.
I was trying to catch a bird. They don't.
All right, other than a hydrometer, another tool that you can use, a more sophisticated tool, is a refractometer, which is what's pictured over here on the left. That can also be determined to figure out the ratio of antifreeze to water, and then we can figure out the freezing point based off of that. This is probably one of the most nerdiest things that we get to use in automotive class. Okay, this is a refractometer. Okay, typically speaking, these can get pretty darn expensive, like a couple $100 just for this. Okay, I think I spent $40 on this. So when you're utilizing this is a little bit more expensive, pricey tool, but it's stupid cool. The science behind how we can utilize this is, I think it's the coolest thing ever, right? So this is like less than $10, pretty cheap. This thing here, at least this version, is $40. So how do I use this particular tool? I'm gonna get a little pipette. Remember like science class, pipettes? So this is just like the bulb on the hydrometer, right? I squeeze this, I stick this in the coolant, it sucks up some coolant. I'm gonna take my hydrometer out, I'm gonna go ahead and open up this, and I'm gonna literally put about 2 to 3 drops of coolant on this part of the refractometer. Then just like a microscope, I'm gonna take this, put that on, it kind of spreads it out, and then I'm gonna actually look through this. So light is gonna hit this, and then I can see the inside. Okay. Now I can't describe really to you what the inside of this looks like. I'll have to show you a picture. It's kind of like this right down here. Okay. This is a very, 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 very basic version of what you see. Okay. So let me talk to you about the science behind how this works. Okay, and then yeah. Okay. Excuse my crude drawing. Actually, you know what? Hold on a second.
Looks like a person in a pool.
Oh yeah, I can change colors, folks. It looks like a person in the pool. That's because that's exactly what it is. Best drawer ever.
Did I
Okay.
win?
So what?
Did I win?
You won. Pictionary. Okay. Most everyone in here has probably been in a pool before. Okay. If I'm a person that's standing on the concrete out of the water, as the light is coming in here, right? It hits the water, and then what happens to the light?
It reflects.
It refracts. That's the technical term, right? It bends the light because water is more dense than air. Okay? So it refracts the light. So when you look at this person that's in the water, right? You see the top part that's out of the water? Right, Chase? And then you can still see the person underneath the water, and it looks like they're like 2 inches tall. Right? That's because of the way that the light refracts. A refractometer uses how light refracts to indicate how much water and coolant is combined together, because the more antifreeze you have in your coolant, the different angle at which the light refracts. So if I have 100% water, it refracts at a particular angle. If I have 50% antifreeze, again, that refracts at a different angle. So what that looks like on the inside here, I got this little deck that I'm looking through, right, in my eyelet. There's going to be a blue-white, basically half, and there's going to be a line created. That's the refraction line. and then there's a scale in here, right? 0, 10, 20, 30. And that's going to say, hey, because of this refraction amount that's occurring, this is how much antifreeze I have, which means this is how good the freezing point is for that coolant. Okay? Does that make sense of how we came up with that? Because that's how that works. It's stupid cool. All right. Now keep in mind that we can use refraction to do a lot of different things, and in our particular example, we're just going to be focusing on coolant. All right, Mightyvac Coolant System Pressure Tester. What do I got? This thing right here. This is another instrument that we're going to use to test our coolant system. This here, when I squeeze this, is going to push air out, and using a hose, I'm going to then pressurize my coolant system. Once I get it up to the proper amount, then I'm going to sit and wait, and I'm going to look at this needle. It should not move if it's functioning correctly. If that needle is moving down slowly over a period of time, I've got a leak. Okay? I can also use this in conjunction with this. I can put the radiator cap attached to this, and I can then pressurize the radiator cap. Once I get to, let's pretend 15 psi for this example, that radiator cap vacuum port should open up and relieve the excess pressure, which means I can pump this as hard as I want. I should get to 15 psi, and I should never go over it. Okay? This is a more expensive tool as well. It's kind of fun. Okay? Coolant hydrometer, again, this is the one that we're going to have you all use, but they do come in a variety of different shapes and sizes. All use specific gravity to measure the concentration of antifreeze to water. Again, here's our refractometer. This gives you a better picture of what that looks like on the inside. Okay, you can see it very clear blue and white, and you just follow that line to a particular number, and that tells you the temperature at which that freezes. We have our coolant test strips. This again is really cool. We're actually going to use the acidity of the coolant to indicate our freeze and boiling temperature. So literally you're going to take one of these out. If you've ever tested the chlorine level in a pool, you take this, you dunk it into the coolant. This is going to change colors. And then what you're going to end up doing is comparing that to the colors that are on the side of the bottle here. And you can kind of estimate the boiling point and the freeze point of that particular liquid, along with its corrosion level. Pretty fun. Is that it? I think that's it. So there we go. All sorts of fun stuff there. Any questions? Oh, I'm getting a phone call.
How's it good? Like, why? And what? I don't see.
Oh, you beat me.
Yes. Sure thing. Yep. I don't know. There's one in the office.
Cheers.